Assalamualaikum Doctor. I am Izzati, and in this video I will explain how I solve the question 2 in lab for the lab 8. So this is the circuit that given. Okay. So A, calculate the initial value of I. So initially the circuit is closed, the switch is closed, and this is how initially the circuit will look like. So when the switch is closed, the inductor will act as short circuit, like over here. Okay, so first of all, I calculate the value. I parallel together the 6 ohm resistor and 30 ohm resistor, and the answer I get is 5 ohm. So I drew the new circuit over here. And then by using the voltage division, I calculate the voltage that flows through the 5 ohm resistor. So the formula is 5 over 5 plus 3 times 120, which is the voltage source. And the answer is 75 volt. So lastly, to find the I use the Ohm's law, which is I equal to V over R equal to negative 75 over 5, and the answer is negative 12.5 ampere. So the reasons why the answer is in negative is because if we look over here, the current is flow through from negative to positive voltage drop. So that's explain why the answer is in negative value. So B, calculate the initial energy stored in inductor. So the formula for this is omega naught equal to L I naught square over 2. And then just substitute the value, which is for inductor 8 millihenry. For I naught is the value that we get from the above question, which is negative 12.5 square over 2, and the answer is 625 millijoule. And C, what is the time constant at t is greater than 0? So when t is greater than 0, it means that the switch is open and the circuit will become like this. So to explain more clearly, from this above circuit here, when it is open at t is equal or greater to 0, the only component that left in the circuit with the inductor is 2 ohm resistor. So we will use the 2 ohm resistor to find the time constant. So the formula for time constant is tau equal to L over R equal to 8 millihenry over 2 ohms, and the answer is 4 milliseconds. Next, what is the numerical expression for IT for t greater equal to 0? So when t is greater equal to 0, the formula that we use is IT equal to I naught E negative t over tau. So just substitute the value that we get from the above question. So for I naught, just substitute negative 12.5 e to the power of negative t over 4 millisecond, and the answer is negative 12.5 e to the power of negative 250 t ampere. So the last question, E, what is the percentage of the initial energy stored that has been dissipated in the 2 ohms resistor 5 milliseconds after switch has been opened? So firstly, I calculate the initial energy stored in the inductor. So by using this formula, however, I need to find the initial current for 5 milliseconds. So by using the numerical expression that we get from D, substitute the value of t that given from this question into the expression. So it will become negative 12.5 exponent to the power of negative 250 times 5 millisecond. And the answer for the current is negative 3.89 ampere. So substitute the value that we get from here into this formula, and the answer for initial energy stored in the inductor is 51.3 millijoule. So since the question asks to find the initial energy stored in 2 ohm resistor, so I minus the initial value, the initial energy value in inductor with this answer we got over here. So the answer is 507 3.7 millijoule. So this is the initial energy that stored as initial energy stored that has been dissipated into ohm resistor. So the question asks the percentage. So to transform this answer into percentage, just divide it by 625 and times it with 100%. And the percentage initial energy dissipated is equal to 91.8%. Thank you, Doctor.